Welcome to STEM Professionals. In this video, we will discuss the problems and conceptual exercises of Chapter 2 from the book James S. Walker. So let's start with the video. So here in this question, we are given with this VT graph of a person. Now we need to find the displacement of the person for each of the following segments: segment A, segment B, and segment C. Now to find the displacement, there are multiple ways. Either you can do one thing, you can find the area under this curve to find the displacement for this segment A, and this would be the displacement. And for segment B, let me show it with a different color. This area would show the displacement for the segment B, and this area would show the the displacement for segment C. You can use this method that this thing I have already discussed in the previous videos, that how this area is will give you the displacement. Now next method we can use the equations of motion that we derived earlier, and the third method would be you can find the average velocity for this segment of the motion, and then you can multiply it with this time to find the displacement. So let's use this method to find the answer. Now average velocity, we know that for constant acceleration, average velocity is given by 1/2 v naught plus v, where v is this is v average, where v naught is the initial velocity and v is the final velocity. So for segment A, the initial velocity is 0, so we can write that v average, this would be equals to 1/2. Initial velocity is 0 plus the final velocity becomes 2. From here we can see from this graph, this is 2, so this would be 2, so that would be 1 meter per second. Now for this time interval, the average velocity is 1 meter per second. Now we can easily find the displacement delta x, which would be equals to the average velocity multiplied with the time interval delta t. So this is 1 meter per second, and delta t we have 5 for this is 10 seconds. For this time interval, the time, this is 10 seconds. So we can multiply it with 10 seconds and we'll get the displacement to be 10 meter. So this is the answer for the A part. Similarly, we can solve the B part, this one. So first we're going to find the average velocity for this segment. So part B, so average velocity would be equals to 1/2. Now in this case, initial velocity is 2, so 2 plus final velocity becomes 6, so 6. So that would be 8/2, which is 4, so 4 meter per second. Now the displacement for segment B would be average velocity multiplied with delta t. Average velocity in this case is 4 meter per second, multiplied with the delta t we have this is 15 minus 10, that is 5, so 5 seconds. So we'll get this answer to be 20 meter. So this is the answer for the for the B part. Similarly, we can solve the final case, the segment C. Same method we can use, and I'll be just writing the answer. You have to do on your own. So the answer would be, for the C part, delta x would be 40 meter. Now you are driving a car at some speed, and the brakes in your car creates a constant deceleration of 4.2 meter per second squared, regardless how fast you are driving the car. Now suppose you doubles your driving speed from 18 meter per second to 36 meter per second. Now in the A part, we have to tell, does the time required to stop a car increases by a factor of 2 or by a factor of 4. So this is the A part. We're going to solve the A part first. Now earlier we studied that the change in time delta t is equals to change in velocity divided by the acceleration. So time required to stop the car would be calculated from this equation, Now, since the speed is doubled from 18 meter per second to 16 meter per second, the rest everything is same, that is acceleration is same. So if velocity is doubled, then this delta t would also be increased by a factor of 2. So the correct answer would be that it would increase by a factor of 2. So this was the A part. Now in the B part, we have to verify the answer to part A. So basically we have to verify that is it correct or not that we have calculated in this part. So delta t we have V final minus V initial divided by A. Now since this is a case of deceleration, so we have to take a negative sign here. Now the final velocity becomes 0 after applying brakes. Initial velocity in the first case we have 18 meter per second divided by negative of A is 4.2 meter per second squared. So this would be equals to 4.3 second. Now in the second case we have the speed is increased from 18 meter per second to 36 meter per second. So this time delta t stopping time would be equals to final velocity becomes 0. Initial we have 36 meter per second this time divided by A is minus 4.2 meter per second squared. So that would be equals to 8.6 second. So here we can see that the time is increased by a factor of 2. It just doubles. Therefore, we have verified this answer. So here we are given that a particle accelerates for 0.45 seconds with acceleration 6.24 meter per second squared. Now at the end of this time, the particle velocity is 9.31 meter per second. So let me show it on the figure. Here this is time t equals to 0 and let the initial velocity be v0. Now here this is time t is equals to 0.450 seconds and the final velocity becomes 9.31 meter per second, and during this time interval the acceleration is constant, which is 6.24 meter per second squared. Now we have to calculate the initial velocity vi. This thing we have to calculate. Now since the acceleration is constant, so we can use equations of motion that we derived earlier. So v is equals to v0 plus at, this equation we derived. Now here this v is the final velocity, which we have 9.31. So this is 9.31 meter per second is equals to v0 is the initial velocity that we have to calculate. So v0 as it is plus a is 6.24 meter per second squared multiplied with time. So time we have 0.45 second. Now from here we can easily calculate this v0. So v0 would be equals to 6.50 meter per second. So this is the answer. Now here in this question we are given that you are driving the car at speed 18 meter per second and heading due west. So let this direction be the west direction. Now when you see traffic light turns red, you apply the brakes until you stop the car. So let at this position the velocity becomes 0. Now we have to calculate the average velocity during braking, and we can assume constant deceleration. Now this is the initial velocity which we are given to be 18 meter per second, and here after applying brakes the velocity becomes 0. So the average velocity we studied that it is equals to 1 over 2 v plus v0, where v0 is the initial velocity and v is the final velocity. So 1 over 2, final velocity we have 0 and initial velocity we have 18 meter per second. So that would be equals to 9 meter per second. So this would be the average velocity and the direction would be the west direction.